Hi, hello, and welcome to this series on AWS networking. And in this video, we are discussing VPC or the Virtual Private Cloud. So, as we know, VPC is one of the most fundamental building block or component of AWS networking. So, we are going to understand the functions of VPC performs with a real world analogy in this video. And a VPC doesn't functions in isolation. It also has other associated networking components. So in this video, we are going to briefly understand the functioning of each of these components as well with a lab session on VPC. So first we will cover the theoretical part of it and then we'll move to the lab. So let's move on to the next slide. So by definition, VPC is a private network that you define on AWS platform and create resources within it. So what you see here in green are the two VPCs that have been created under the region US East 1. So before diving deeper into VPC, let's try to draw a real world analogy so that it is easier for us to understand the key function that VPC performs. So let's say this diagram depicts a typical office network. So here what you see is a router and a couple of switches that are implementing a physical LAN in your office area. Now, this physical LAN is getting clustered into individual functions like manufacturing, sales, HR by implementation of VLAN 1, 2, and 3. So, VPC is analogous to these virtual LANs in a way that it helps uh, cluster or isolate uh, the resources that you have within your VPC from any external network within the AWS. So, network engineers use virtual LANs for multiple reasons, including improving performance or tighten the security or for ease of administration. So, VLANs can improve performance for devices on them by reducing the amount of traffic a given endpoint sees and processes. Similarly, engineers can also define traffic handling rules per VLAN or per VPC. For example, they can set rules to prioritize video traffic to, say, a conference room that is frequently used by sales team that has telepresence devices and which requires good amount of bandwidth for the teleconferencing devices to work properly with the video calls. So these clusters can be targeted separately for applying specific rules by the network administrators. So a VPC where one has resources within it. So by default, these resources are isolated within VPC 1 and do not have any visibility to external network or other VPC by default. And there are controls in that can be put in place to provide visibility for the VPC resources to external network or other VPCs. And we will discuss that at the later part of this video. So as understood, VPC is logically separated from other private networks on AWS and from other VPCs as well. So as discussed, VPC is one of the fundamental networking component in AWS, but it cannot work in isolation. It also requires other associated components like Subnet, Internet Gateway, routers, security groups, network ACLs, etc. to perform the complete function of networking. that you want to achieve within your AWS environment. So let's move on to the next slide and deep dive a little to understand the function of each of these associated networking component in detail. So VPC is a service that lets you launch AWS resources in a logically isolated virtual network that you define. It can span multiple availability zones. As one of the AWS foundational service, Amazon VPC makes it easy to customize your VPC network configuration. You can create subnets to manage the resource isolation for the resources you create within your VPC. You can create a public facing subnet with your web servers that have access to the internet. It also lets you place your backend systems such as databases or application servers in a private facing subnet. And these private subnets do not have any internet access. Hence, they are called private subnets, wherein the resources are in complete isolation from any of the outside networks. So Amazon VPC lets you use multiple layer of security, including security groups and network access control lists to help control the flow of traffic to the resources within the subnets. So both security groups and network access control list have set of inbound and outbound rules that you can define based on IP address and ports in order to um, allow the traffic that can flow into the subnet. So you have complete control over your virtual networking environment, including selection of your own IP address range, uh, and creation of subnets and configuration of route tables and internet gateway. So you can use both IPv4 and IPv6 for most of the resources within your VPC. You can create multiple VPC within a region. You can have a limit of 5 VPC by default under your account, but you can request an increase on that amount. So each VPC has a CIDR block. That's the overall block of address from which you then create the addresses you assign to your subnets. So it's like a master block of addresses per VPC, which is also called the primary CIDR block. So each VPC has different one of these. So in this case, we have got two VPC, so they will have different CIDR blocks as you can see here. So as you learned in the earlier lesson, CIDR stands for classless interdomain routing. From the primary VPC CIDR block, we can then create the network IDs for our subnet, and they will all fit within the primary CIDR block of the VPC, but they will have a different subnet mask so that essentially it is a subset of the available addresses in the primary CIDR of the VPC. And this is why it is really important to make sure we specify our CIDR blocks correctly so that we have enough network and enough hosts per network. We have covered in detail the concept of IP addressing and subnetting in our IP addressing premier video series. And if you are not clear about how IP addressing works, I suggest you to please go through my video on IP addressing, and it will give you a strong foothold to move forward with the IP addressing concepts, which would be useful in the further lessons. So I will provide a link in the description so that you can go through that video. So we will cover that separately. And so here we have two VPCs now, each with different CIDR block, and then each one with different subnet, and each subnet has its own CIDR block. Like a traditional network, a VPC consists of at least one range of contiguous IP address, and this address range is represented as a classless interdomain routing or the CIDR block. The CIDR block determines which IP address may be assigned to instances and other resources within the VPC. You must assign a primary CIDR block when you are creating a VPC. You cannot change the primary CIDR block once it is created. And after creating a VPC, you divide the primary CIDR block into subnets that hold your resources. Please note that the IP range of the CIDR block assigned to the subnet fall within the primary CIDR block associated with the VPC. There are different ways to represent a range of IP address, and the shortest way is by a CIDR notation, sometimes also called the slash notation, and the valid range is between slash 16 to slash 28. So what it means is that a slash 16 prefix for a network 10.0.0.0 means a total of 65,534 IP addresses, and the range starts from 10.0.0.1 to 10.0.255.254. Now, the subnet CIDR should fall within this IP range. As you can see here, all the IP fall within the primary CIDR block. Although you can specify any valid IP range for your VPC CIDR, it is to be noted that in order to avoid conflict with public IP ranges listed below, we also need to remember that first four and the last IP addresses are not available for use as it is reserved by AWS. AWS also recommends you to use CIDR blocks from the RFC 1981 ranges as shown in the table below. In addition to the primary CIDR block, we can also assign a secondary VPC CIDR block. The condition is that it must come from either the same address range as the primary or a publicly routable range, but they must not overlap with the primary or the secondary block. You may let AWS assign an IPv6 CIDR to your VPC, unlike the primary CIDR, which is an IP prefix you choose. You can't choose your own IPv6 CIDR. Instead, AWS assigns one to your VPC at your request. The IPv6 CIDR will be publicly routable prefix from the global unicast IPv6 address space, so all IPv6 addresses are reachable from the internet. If you plan to connect your VPC to another network, whether an on-premise network or another VPC, be sure the VPC CIDR block you choose doesn't overlap with the addresses already in use. Now let's have a quick look at the other components. So we know that VPC exists within regions. A VPC can belong to a single region, whereas you can create multiple VPCs in a single region. Then we have already seen CIDR blocks, and it stands for classless interdomain routing. So when we create a VPC, we must specify a range of IPv4 addresses for the VPC as the primary CIDR block, and this is just a method for allocating the IP addresses for the VPC for IP routing of the resources that we are going to launch within that particular VPC. So, as discussed for VPC and other associated networking components, we can use IPv4 and IPv6 with some exceptions which are enlisted in this table. Like, for example, the CIDR notation allowed for VPC is /16 to /28 for IPv4, whereas for IPv6, /56 is the only allowed slash notation. Similarly, say for example, if you want to use IPv6 for elastic IP addresses, it is not supported, whereas IPv4 is supported for elastic IP addresses, NAT Gateway, and VPC endpoints, whereas you will see that IPv6 is not supported for these networking components. So you can have this table as a quick reference for IPv4 and IPv6 application. Around the use of IPv4, there are certain restrictions on what IP um, addressing blocks can be used, and that is enlisted in this table. We remember that there are certain IP addresses which are reserved by AWS, and it is always good practice to refer to these guidelines when it comes to allocating uh, the CIDR blocks for your VPCs or your subnets. So you can have these couple of slides as a reference for the restrictions and permitted associations around the IP address ranges. Now let's have a quick look at the subnets. So a subnet is a part of the VPC that has a CIDR block. So VPC spans multiple availability zone, and what it means is that if I am creating a VPC in region US East 1, which has 6 availability zones named US East 1A to 1F, I can create resources within any of these 6 availability zones within the region where the VPC is located, which is US East 1 in this case. So you can create one or more subnets within your VPC, and a subnet will span only one availability zone at a time. Typically, you will create a private subnet which contains resources that are not exposed to the internet or outside of the VPC, and you will create a public subnet for resources that have access to internet or are reachable from internet. The next set of networking component are NAT devices. They are of two types, NAT Instance and NAT Gateway. They both perform the same function, more or less, of network address translation, but the only difference is that NAT Gateway is a fully managed service where an end user doesn't need to take care of the scaling needs of these devices. It is fully managed service from AWS, so it scales as per the changing needs. Whereas a NAT instance is an EC2 instance with NAT capability, which stays in public subnet. So end user is responsible for managing the scaling of NAT instances. So all private instances go through the NAT device if they want access to internet. Example, say if you have a Ubuntu operating system running on an EC2 instance, which is sitting in a private subnet, and this subnet doesn't have any access to the internet via the internet gateway, but this instance needs to download patches for updating the operating system or updating the repositories for any application stack. It needs to connect to the internet and download these patches in these kind of scenarios where we want the resources within the subnet to access the internet and not vice versa. In such cases, we can use NAT devices. So now the next component that we are discussing is the Internet Gateway. So it's again a fully managed service from AWS. So it is highly available VPC component that allows communication between the resources in your VPC and the internet. So two main function that it performs is providing access for the internet for VPC resources, and the next function that it provides is that of network address translation. The difference between NAT gateway and internet gateway is that NAT gateway works at a subnet level, whereas internet gateway works at the level of VPC. So the next component that we have is route table, which are a fundamental networking constructs used to control the traffic between the subnet and the virtual private cloud. So route table consists of a set of rules that are called routes that specify how traffic is directed to the different destinations. So a default route table is automatically created every time you create a VPC. But in addition to and it is called the main route table. And in addition to that, you can create more route tables to meet specific routing requirements. And each VPC, as I told, must be associated with a route table, and that's the reason why a default route table or the main route table is created as soon as the VPC is created. You can associate multiple subnets with a single route table or create separate route table for different subnet. And each route table can have multiple route, including routes to local VPC resources, other subnets within the VPC, and external networks like internet, etc. And you can also prioritize the routes by specifying a route table association order, which determines the order in which routes are evaluated for the incoming traffic. And route tables can also be used to configure network address translation gateways, which allow private subnet to communicate with external networks. The next component that we have is a security group. A security group is something that is associated with the instance or the appliances that are available or provisioned within the subnet. Hence, they are the first layer of defense for an instance. So it contains a set of incoming and outgoing um, rules that you can uh, apply. So it's called inbound and outbound rules that you can apply for incoming and outgoing traffic. So where you define which port and protocols are allowed, you can also whitelist IPs that are allowed to access the resources. And remember that security groups are useful if a port is open for an inbound traffic, the outbound traffic on the same port is allowed automatically. So that means it is stateful and not stateless as compared to network access control list, which first and foremost is applicable on a subnet level, as we saw in our earlier diagram. Let me switch back to that diagram to illustrate. So we had network access control lists, which were applicable on a subnet level. So all the rules that are defined on network access control list level is applicable to all resources within the subnet, whereas a rule that is applied on a security group is only applicable to the instance or resource to which that particular security group is associated with. Now, having said that, let's also understand where it says it is stateless, meaning that you must specify both inbound and outbound rules for the traffic that needs to be allowed or opened. So we'll have to explicitly open the traffic both in the inbound and outbound section. It is not stateful like security groups where if you are opening the inbound connection, outbound connections are also automatically applied. So this needs to be kept in mind. So before wrapping up the theoretical part, so let's have a quick recap of what we have covered. So a virtual private cloud is a virtual network dedicated to your AWS account. It's analogous to having your uh, own data center inside your AWS. It's logically isolated from other virtual networks, just like a virtual LAN in AWS cloud, and it spans all availability zones in the region where the VPC is created. If your account was created after 2013, December 2013, it comes with a default VPC, which we will see in the lab session. And our default VPC has a default subnet in each availability zone in the region, an attached internet gateway, route in the main route table that sends all traffic to the internet gateway, DNS settings that automatically assign public DNS host name to instances, EC2 instance that is launched in default subnet automatically has access to internet because there is a main route table that sends all traffic to internet gateway. If you don't specify a subnet when you launch an EC2 instance, one of the default subnet is automatically selected. Non-default VPC can also be created where you can configure it as you need to add non-default subnets and other components. You can also specify an IP range for the VPC, add subnet, add gateways, associate security groups, and by default, you can create up to 5 VPCs per region. And when you create a VPC, you assign it in an IPv4 CIDR or an IPv6 CIDR block or both IPv4 and IPv6 CIDR. In that case, where you apply both IPv4 and IPv6, it is called a dual stack. Private IPv4 addresses are not reachable over the internet, whereas IPv6 addresses are globally unique and can be configured to remain private or be reachable over the internet. Okay, so now that we are done with the theoretical part, it's time to deep dive into the concepts with a lab session. So in this lab, we are going to explore the default VPC and all the components that we saw in our previous slides that are associated networking components like subnet, internet gateway, etc. So a lot of these components are created by default as soon as you set up your AWS account. Now, this AWS account is a prerequisite for moving forward with this lab exercise. And if you're not sure about how to creating your own free tier account, I suggest you please go and watch the video link provided in the description box to have a quick understanding on creating this account. So I suggest that you set up your own account before moving forward with the next steps. So once you are done setting up your account, we will log into your account via the AWS Management Console and we'll explore the default VPC, and then we'll launch an instance into your VPC, and then we will try to connect over SSH into this EC2 instance which is deployed in your public subnet, and we will also deploy a HTTP server, Apache HTTP server onto this EC2 instance and deploy a test web page, and we'll try to access this web page from public internet in order to just demonstrate the flow of traffic from public internet into this public subnet within the default VPC. And as we go along, we will also explore all the other default networking component that comes created along with your account creation, like default subnets, default internet gateway, default route table, etc. In the fourth step, we'll do a quick cleanup before closing up this exercise and move to the next part of this lab, where we'll create custom VPC and all the custom components and configure them in the next part of this lab session. So now we log into our management console and we can either type VPC and directly go into the VPC dashboard. But for service discovery sake, if you want to go via the service categories, it falls under networking and content delivery. and then you can see that we have the VPC at the last option. We can click here and that will redirect us to the VPC dashboard. So now that we are logged into the VPC dashboard, you can see here that the VPC count is 1, which is indicating that there is a default VPC created as soon as the account was created. And below we have all the other default networking components created along with the account creation. Now we are in US East 1 region, so this VPC that we are talking about is created within US East 1. And if you go to the global infrastructure section on AWS North Virginia, it has 6 availability zones as shown here. So this means that we are talking about 6 availability zones and hence 6 default subnets, with each subnet dedicated to each of these availability zones. Now let's go into the VPC section and explore the properties of this default VPC. So once you click here, you will see that the default VPC flag is set to yes. That means that this is a default VPC, and that's how you distinguish between a default and a non-default VPC. Now what you see here is the CIDR block, or the primary CIDR block that is associated with the default VPC, which represents a range of IP address. Now this CIDR block gets segmented to define the CIDR blocks for the default subnets that are associated with your VPC. Now in the resource map below, as you can see here, we have this VPC, and under this VPC we have 6 subnets. So basically, as we saw from the global infrastructure, that US East 1, that is North Virginia region, has 6 availability zones. So by default, what AWS does is that it gives you a VPC and in each of the region, and for each VPC it creates a subnet in each of the availability zones. So this subnet is again a default subnet. So if I go to this subnet, for example, if I go to subnets, you will see that we have 6 subnets already created here. And when we click on any subnet, you would see that the default subnet property or the flag is set to yes. So this is how you figure out which is a default subnet and which is not a default subnet. And then you would see that with each subnet there is a IPV4 CIDR block associated with it. So this is a segment of the primary CIDR block associated with the VPC. Now let's go back to the VPC and explore further. So we have seen the CIDR block. Now another component that is associated with a VPC, whenever you create a default VPC or even when you create a custom VPC, for sure there would be one root table that is going to be associated with that VPC. And what is a root table? We discussed root table is an entity that controls the flow of traffic within your VPC resources and outside of it. So let's see this in action. So we can just click on this route table and we can see that there are certain entries. So you can see that this route table is associated with which VPC here, and then you have a flag which says that this is a main route table. So what it means is that in addition to the main route table, there can be other route tables also created and associated with a VPC or subnet. Always there is going to be one route table created as soon as you create a VPC. So within this route table, you have something called routes, which are nothing but these individual entries that you have under a route table. So let's go back to the VPC. And so under VPC, we have seen that there are various subnets that are associated with this VPC. And using this resource map, you can identify the VPC and then the associated subnets. You could have a look at the availability zones and the CIDR blocks directly from here, and then you can see the associated route tables with each of these subnets. Remember that these are default subnets, and because it is default, it is public in nature, and that is because the route table to which it is associated has an internet gateway, has a route that directs the traffic flowing in from these subnets to an internet gateway. And we discussed that an internet gateway is a device that sits on the perimeter of a VPC, and it provides the capability of routing traffic from the VPC to internet and vice versa. So in case a route table has an entry with the internet gateway, and that route table being associated to a subnet, then these subnets will become a public subnet, and any of the EC2 instances that you launch within these subnets will be able to access resources on the internet, and entities on internet will be able to access the EC2 instance, whether it is via your HTTP protocols or SSH, and it depends on like whether you are opening those traffics using the network ACLs and security groups or not. So let's have a quick dive into the route table and see what it looks like. So this is a default route table that is created here and associated with the VPC. And whenever you create a VPC, a default route table will be created, and that is called the main route table. And when you look into it, you will see that there is something called routes, and routes are the individual entries or the individual rule you can think of, which helps determine the flow of traffic within the VPC and outside of the VPC. So for example, here if you see that this is the CIDR block for the VPC, hence the local traffic is getting directed to the VPC, and then the traffic from all IP addresses on the internet is getting allowed through the internet gateway, and this is a default internet gateway. And because this entry is there, hence any resources within this VPC group can access this traffic getting routed via this internet gateway. Another aspect to it is that the traffic can be routed to a resource that is launched within a particular subnet only if there is a subnet association with the root. So if we click on subnet association, we scroll down and we see that this route table is also associated with all of these subnets that are created by default. And here it says that subnets without explicit association, meaning that it is an implicit association. So for default subnets, the association is implicit in nature to the main route table. If there is a custom route table, then we have to explicitly define an association. So we can click on edit subnet association, and then we can select a particular subnet, and then we can save the association for a certain custom route table that we have created. So if you look at this set of subnet associations, all of these subnets are currently associated with the main route table, and the main route table is having a route rule that directs traffic to the internet gateway. That means all of these 6 subnets are public subnets, because you could expose the resources or instances that you launch within each of this subnet to internet traffic. If you want to make all of these subnets private, what you can do is that you can go to the routes and you can simply delete this entry, and what this would mean that there would be no exposure for these subnets to internet, because there is no internet gateway attached to the route table in that scenario. Other way around is that you could create, if you want one of these subnets out of this to not have traffic from internet flowing in, that is, you want to make one of these subnets private, what you can do is you can disassociate this subnet from the main route table. You can create a custom route table and you can associate, and in that custom route table you only have the local routing and don't keep any routing via the internet, and that will make it private. We will discuss this in more detail in the next section, wherein I will be creating the custom subnets and custom VPCs. So I will show all this in action in the next session. So for now, just understand the various configuration parameters and components that we discussed as part of our previous slides. So let's go back. So we are on the VPC and we see that these are the various subnets associated with the route table, because route table has entry to the internet gateway. Hence, all the traffic from the internet can be routed via the internet gateway that is configured in the route table to all the subnets that are associated with the main route table. Now, when I go back to the VPC dashboard, we see that there's one VPC. We have 6 default subnets created. We have one route table, which is the main route table for the VPC. Then we have one internet gateway by default created for us. And then we have something called network ACL and security groups. So what is a network ACL? Network ACL can be associated with the VPC or it can be associated with the subnets. And what it contains is a set of rules for the inbound and outbound traffic. So for example, if you see here, there is a set of inbound rules and outbound rules. And what it defines is that all traffic is currently allowed from all these IPs. If I want to define a custom rule, I can say add a new rule, and I say this rule number 101. I say just allow, say, SSH from a certain IP, say 1, and you can add this, save changes and add this rule. So this way you can actually define custom rules inbound for the inbound traffic as well as outbound traffic, and then associate this network access control list to subnets as well as VPC to control the flow of traffic in and out of the subnets and VPC. In addition to network access control list, you have security groups which function similar to network ACL, but it is stateful in nature, in sense that if I am defining an inbound rule, then the outbound rules are automatically applied. Suppose if I am allowing, say, SSH port for all these sources or all the IP address range, then it will automatically assume that it applies to outbound rules as well. I don't need to explicitly define it, but if I am working with a network ACL, I will have to explicitly define the inbound rules and explicitly define the same rule in the outbound rule. Only then it will get into effect. Otherwise, what will happen is that the rule will apply for inbound rule, but if I have not applied it on outbound rule, it will not be in effect. Whereas in security group, if I have applied a certain rule for inbound connection, automatically it is applied for the outbound rules as well. So that is all the exploration part of it. Now the next step that we identified that we'll be doing is that we'll be launching an instance into the VPC, and then we will be connecting to this EC2 instance via SSH. And then after that, we'll be destroying that instance. So let's go back. So let's go to EC2. Under EC2 instance, what we'll do is that we go to EC2 dashboard, or we can say launch an instance from here. I will call it Tech Hub VPC demo. I will select the Ubuntu AMI for my instance. I will keep it to T2 micro so that it falls under the free tier, and let me create a new key pair that I will call, and let me download this .pem file. Then under the network setting you can click on edit, and now because we don't have any other VPC, so the default VPC is the default selection here where this EC2 instance would be launched. And then if I don't give any preference for the subnet, any of these 6 subnets would be picked up and it would be launched. But I would give my preference for availability zone US East 1A to launch my instance, and I keep the auto assign public IP to enable, and that is all that we require here. Now with respect to the security group, I would just see whether I have all the necessary ports enabled. So here it says SSH port being open from anywhere, so that I could SSH in. And in addition to that, what I will do is I will add the HTTP port as well, open from anywhere. So with that, I am done with all the configurations. I will launch the instance, and let me go back. So this is the instance in the VPC dashboard that I created. So as you can see from instance state, it is in a pending state. And let me just select this instance to see if a public IP is already associated. So it is. So let's copy this public IP address. And what I would do now is that I would take my SSH client, which in this case is xterm, and I will configure this client to connect to this VPC. Okay, and yes, with that we are logged into the EC2 instance that was created here. Now, right now, what we have done is that we have been able to connect to the instance that we just now created via SSH, and this is being made possible because we have EC2 instance launched in a subnet, which is this subnet, and this subnet, when we look at it, it is associated to a route table, and this route table in the routes has an entry to the internet gateway. Now, what happens if I edit the routes to remove this entry from the route table? Okay, so I am removing this entry from the route table, and you can see that now the internet gateway is not associated. Now I go back to my terminal, I exit this connection. Sorry. So I think the connection is already lost. So you can see here that this was the instance that we were trying to connect to. So now when I double click on this client, so it should be connecting, but because we removed the internet gateway from the route table, now this instance is not allowing us to connect over the internet. So now we go back just to show you the function of the internet gateway. So I will edit the routes again, and I will add a route, and I will say allow from all IP addresses, and then click on the internet gateway, and since we have only one, it is getting listed here, and then click on save changes. And now again, when I go back to and just press R to revive the session, you will see that this is now able to successfully connect. So with this, I hope you understood how internet gateway facilitates the connection or facilitates the traffic over internet into the VPC resources. So now what I will try to do is that I will try to install a HTTP server on my Ubuntu instance. So I will just install a Apache server. So just follow the steps here. So first I will go and update my OS. So now I am installing the Apache web server. And I will create my own index file. Localhost to verify what is getting served. The web server should show us hello from TechUp. So let's go back to the web browser and copy the instance public IP address, and if we call it over HTTP from browser, you can see that it is resolving to the EC2 instance. If we go back to the instance, we see that under security there is a security group named Launch Wizard 1, which has certain rules defined. And let's see what the rules. So we have opened port 22 and 80. So 80 is on which HTTP works. That is why you were seeing this web application getting served over port 80. But if we say, for example, we don't want this instance to be accessible via port 80, and we say, for example, we edit the inbound rules and allowing any traffic via the HTTP port and say this rule. Now if you hit enter, you will see that it's not resolving. So if I just close this and I put this up, so this, you can see that this traffic is not getting resolved to the instance because we have not allowed this port. We have not opened this port in the security group. So on a security group level, it's deny all ports. You have to explicitly open the ports for the traffic to ingress your instance or devices. So I can again click on edit inbound rule, add a rule. I will say enable HTTP from all IP addresses, save the rules, and now if you refresh, you'll see that this traffic is getting served. So that is the function that the security group performs. Similarly, you can do the same from the network access control list as well. So now that we are done with the EC2 instance, so let's see what we have seen here. So we have connected to an EC2 instance from SSH. We have, in addition to that, we have created a HTTP server on the EC2 instance, and then we have seen the function of internet gateway, and we have also seen the function of the security groups. And now it is the step 4 to clean up the instance that we have created, and then we will move to the next section where we will create custom VPC, custom subnets, and all the custom devices associated with it.
So let's go back to the dashboard. Let's go back to EC2, click on EC2 dashboard. Here we have a running instance, select that, and in order to terminate the instance, click on instance state and click on terminate. And with that, you will be terminating this instance, and with that, you rest assured that you are not incurring any cost while this instance is running. So with that, we are done with step number 4, that is the cleanup is done. Let's move on to the next step and see what we are going to see in this next lab. So here we are going to create a custom VPC and subnet and all the associated resources to make this work. So let's quickly have a look of what we are trying to achieve with this architecture diagram. First, we will be creating a VPC, and then under the availability zone, we will be creating the public and the private subnets, and then in public subnet, we'll be launching an instance to give it the access to the internet. We'll be creating route tables and internet gateways, and then creating the routes in the route table to drive the traffic from the public subnet to the internet gateway, so that instance on this public subnet can access from the internet. We will create a private subnet where we will launch EC2 instance, and this EC2 instance we will see that it is not having any internet connectivity to get software updates and patches, and that's where we will be launching the NAT gateway in the public subnet and routing internet traffic from the EC2 instance located in private subnet via the NAT gateway, such that this EC2 instance can get OS updates and patches installed. So in the first part of the video, we will go to create the VPC, and in this first step, we will just create this VPC with this CIDR block. So let's go back to the we have two approaches here, VPC and more, which gives a more wizard kind of approach, but for learning purpose it is good to go the VPC only way. So what I will call this VPC is VPC demo. We are giving a manual input for the CIDR block. So if we go back to the diagram, let's see what CIDR block we have defined. So 10.0.0.0/16, and under the tenancy you can have default or dedicated tenancy. Means if you are launching an instance, either it can be launched in a dedicated hardware resource. For default it will be a shared resource. So with that, we are all done. We can just click on create VPC, and that would create a custom VPC which is non-default, and you can see here that the flag for the default VPC is set to no, by which you can determine that this is a custom VPC. Now what comes with this custom VPC is still that you see that there is a main route table that is automatically created, main network access control list which is by default created with it. You can see that there is no subnets currently created that is associated with VPC as of yet. And in the main route table, you will see that under the routes, we have just the local routing. There is no association with any internet gateway. Now, go back to the VPC, and we can see that this is our TechHub VPC demo that we had created. And we have the CIDR block associated with this VPC. And we have a main route table which is specific to this VPC that is created. And then this is not a non-default VPC. Now, under this VPC, let's create two subnets. One will be a private subnet and another will be a public subnet. What we have achieved in this step is that we have created this VPC with this CIDR block. Now let's move to step 2. So in step 2, we will create this two subnets, private and public subnet, with these CIDR blocks respectively. So moving back to the console, we go to subnets and we create subnet here. We take the VPC under which we want to create this subnet, and this is non-default VPC under which we want to create. So for the availability zone, I'll just define the preference to be 1A, and for the CIDR block, I am taking that is all that I need to do here to create this subnet. We'll create this subnet, 1.0. Okay, let me have a look at the CIDR block once again. So 10.0, sorry, that was the mistake. So there is some level of validation with which it can be determined whether this CIDR block that you are trying to define for your subnet is falling within the same IP range as defined in the CIDR block for the VPC under which you are creating this subnet. So that validation will be in play here. So it is kind of helpful when you are trying to determine the CIDR block for your subnets. We can click on create this subnet, and with this we have this public subnet created. Similarly, what we'll do is that we'll create a private subnet as well. So again, we'll take the VPC and I'll just paste this and call this private availability zone. Again, I will select 1A, and then for the CIDR block I will say don't need to do anything else apart from that. Just click on create subnet. So now if I go to the list of subnets and if I filter by VPC, my VPC is this. So you see that there are 2 subnets that I created under this VPC getting listed here. Now let's go to the public subnet that we just created and see if there is a association to any route table, and if there is an association, what are the routes that are currently configured. So there is only the local routing. There is no routing that is configured to any of the internet gateways. So before moving forward, let's go back and see what is defined as the next step. So under step 3, what we have to do is that we have to create the network access control list for the subnets. Let's go back and create these network access control lists. So what we can do is that we can go down under security and we have network access control list. You can see here that there are a couple of network access control lists listed here. By default, when you create your VPC, you get a network access control list already created, but let's see what are the associations of this network access control list. Click on subnet association and we see that the subnet association is already there. That means the network access control list is already applied to the 2 subnets that we just now created. Now let's have a quick look at the inbound and outbound rules. All traffics are currently allowed from the inbound and outbound traffic. So we are fine with this. So we don't need to create this, although you can also create your custom network access control list and define the rules and then associate it to the subnets. Now let's go back to the slide and quickly see. So now we are going to create an internet gateway, and then we are going to update the route table, the main route table, to have the entry to the internet gateway ID, and that will enable the internet traffic via the internet gateway into the public subnet. And then what we will do is that we will go about creating the EC2 instance to check the traffic to this instance. So now what we will do is that we'll go to internet gateways and we'll click on create internet gateway. We'll call it and we'll just click on create internet gateway. Once it is created, then what we can do is attach to a VPC, and we'll click the VPC that we created and we attach this internet gateway to this VPC. Now we go back to the VPC and we click on the VPC that we created. We click on the main route table and we check the routes, and for the routes what we do is that we can add route. We click on save. Now you can see that there is an entry to the internet gateway, which means that the subnet that we created, the subnets that we created as the public subnet, since it is associated with the main route table, this subnet will have access to the public internet. So now what we are going to do is that we are going to go back to the EC2 console, and what I am going to do is I am going to launch an instance into the public subnet that we just now created. And for the network, we need to define the non-custom VPC, and for the subnet, I will have to take the public subnet right now for this part of the demonstration. Then I will enable auto assign public IP address. For security group, I can use the existing security group. So I'll create launch wizard 2, and under launch wizard 2 I will have my okay, so this is fine from anywhere it is accessible. I will add one more security rule, that is I will allow HTTP traffic from anywhere for this instance, and with that all the configuration done, I can click on launch instance. Now, so the instance is getting launched. It will take a few seconds to appear here. So select the IP address, and again I'm going back to my terminal. So with this, you see that I'm able to log into this instance. I will again, what I will do is that I will update the OS. So with the Apache server, the HTTP traffic flow would be demonstrated. So let me install. So with that, I've deployed the dummy index.html file. Let's see what is getting served over this HTTP server. So CURL localhost, and you see this getting served. Now if I take the IP and hit the URL or IP on the browser, I see that I am getting this request served from the instance that I just launched in the public subnet. Now going back to the private subnet, let's open up this subnet and see how the routing is working right now. Here we see that in the routes we have the entry to the internet gateway. That means that this is a private subnet, but it is not isolated, or it is not private yet, because the route table is routing traffic still via the internet gateway. So if I am actually going to launch EC2 instance, it will have reachability from the internet. So if I don't want this to happen, What I can do is that I can create a custom route table. So I can click on create a route table. I will call it, I will select a VPC for which I am creating this route table, and then I will create this route table. And then for this route table, I will explicitly define the subnet association, and this subnet association is only going for the private. Now if I go into the routes, I have only the default local routing. There is no internet gateway associated. So let me go back to the subnet, private subnet, and see the route tables that are associated. So I have only one route table associated right now. So I can go back to my VPC. I can click here. I can go on the resource map to see how is the association. So for my public instance, I have the default public subnet. I have the default route table which is routing via the internet gateway. But for my private subnet, I have the private route table which does not have any routing to the internet gateway, and hence the instance that I am going to launch within this private subnet will be completely isolated. It will have no connection to the internet in any way. Let me jump to the EC2 section, and I will go and create on launch instance to create my for the network. I'll click on edit and I'll select the custom VPC, and I will use the TechHub demo private subnet to launch my private EC2 instance. Go back to the dashboard. We see this instance that we created here. So we copy the IPV4 address, and now we go into the terminal, and what we try to do is that we try to connect. So we just need to use the SSH command with the new host, and with that we are logged into our EC2 instance that we created in the private subnet. But let's check out whether it has internet connectivity. So for that, let me give it a ping com. So as you can see, it's not getting the reply back from Google. That means that it has no internet connectivity as of yet defined. And how we are going to define the internet connectivity is through NAT Gateway for this instance. So we have created the private subnet, we have the instance. Now what we have to do is that we have to create a NAT gateway in a public subnet, and then create a entry or a route in the private route table to point the NAT gateway ID from the internet. So we have to provide this entry in the private route table after creating the NAT gateway. So let's go back to the console, and now what we can do is we can go to the NAT gateway section and create a new NAT gateway. We can create a new NAT gateway, and for that I will keep a name. For the subnet, I want to launch it in the public subnet, and then I want to keep it public. I associate the elastic IP address and I click on create NAT gateway. Now once this NAT gateway is created, I just need to copy the IP, the ID, and we go to the route tables, and I click on the private route table that I had created, which is this one, and click here, and then I see that there is no entry apart from the local route. I take all IP addresses, and for the NAT gateway I select the NAT gateway entry NAT demo that I created just now, and I click on save changes, and I just go back to my VPC to check the association of the route map under the route map. Now if I look at the private subnet, it is associated with the private route table, and the private route table is directing traffic via the NAT gateway. So now I go back to the terminal and again try to issue the ping command to Google. So I'm still not getting the internet connectivity, so I terminate this and time for the configuration to take effect, and we check this out once again. And as you see here rightly, the configuration was taking some time, and you could see that my EC2 instance in the private subnet is now able to fetch updates from the internet, even though it does not have internet gateway associated with the subnet. So that demonstrates the working of the NAT gateway. So with this, we can conclude the lab session here, and I hope you found the video useful to develop your basic networking concept around VPC and the associated networking components. I suggest you do it yourself, and that will clear all your concepts around the working and functioning of each of these components. So stay tuned for more interesting videos in the networking series. I will be taking up more components, and there may be some of the components that I have not covered in this video in detail. So in the future videos, I'll be putting up other important concepts around networking. So stay tuned, and thanks for watching.